Got it.
Okay.
So welcome everybody to this IT Tech Talk by IT Guild Tech Talk by Pascal Van Dam. Not Jean-Claude, but Pascal Van Dam. Advanced CKAD with multiple architectures. So IT Guild is, among other things, knowledge sharing. And if you have something interesting to share yourself, send an email to me. My name is Peter Isebout. I'm the chairman of the IT Guild Cooperative in the Netherlands, in Amsterdam. If you're interested, we can schedule a tech talk, just like what Pascal is doing right now. You can see all our former tech talks on our YouTube channel, and I will send the address in the chat, even just like my email address. So welcome everybody. Pascal, the floor is yours.
Thank you very much. Okay, welcome all. I believe we're all men here, no ladies, I guess. No worries. Okay, first of all, again, welcome that you actually are here. What I'm going to do today, I'm going to keep it a little bit light. The reason actually for this tech talk is, let me tell you a little bit. I'm Pascal van Dam. I'm from the Netherlands. I'm a trainer for IT Guild and a few other companies. And next to that, I'm actually also the architect for Linux and all things Kubernetes within Atos. We got to know a lot of people. We onboard them on Kubernetes and that kind of stuff. We have to work with a lot of other companies and that kind of stuff. A lot of other developers, engineers, Kubernetes ops, DevOps, and all that kind of stuff. And a lot of the people actually, they actually have the CKAD, for example, certificate. And still, I noticed that I was missing something actually from people were actually missing some experience and that kind of stuff. A lot of stuff actually to get you to getting your CKAD certificate is actually in various courses, the one from the Linux Foundation, the one that we actually bring our own and that kind of stuff. There's a lot of actually stuff on Medium and some other of the forums and that kind of stuff. But still, the things actually that do matter, the things actually that let you make the difference, actually that's still missing. So actually what I did is I proposed to Peter actually to give a small tech talk. In this case, there's on the background actually I've been asked by the Linux Foundation to create actually an advanced course on CKAD. And this is a little bit actually of a smorgasbord of some topics actually that I would like to put into that one. Items I ran into myself that I did investigate a little bit. Actually, Michael knows some of them already because we also discussed them. And we also saw some articles actually on Medium, for example, that in our opinion actually did not get it really right. So actually, I would like to go with them to you, and there are Q&A 3, there might be 4, depending on the time and that kind of stuff. And again, later on, there might be even more talks about this kind of stuff. So, okay, the first part, okay, people are still dropping in, I like that. Thank you, welcome. But just with the introduction, a little bit more about myself. Like Michael, I actually started delivering trainings actually for Hewlett Packard, and I did start doing that actually in 1998, 1999 with the HPX systems, HPX 11 system administration, but also performance and tuning, troubleshooting, and the kernel internals one. Later on, I also got into delivering of courses for AAX, for Solaris, of course Linux and that kind of stuff. I became a certified trainer actually for the Linux Foundation, giving all kinds of Kubernetes trainings. Kernel internals, by the way, last week I had the honor actually to deliver one for BMW in the south of Germany and that kind of stuff. We created also our own variants actually of the CKA, CKAD, and CKS trainings and that kind of stuff. And next to that, I'm also delivering trainings for, we actually created an own training for Golang, which we actually had a workshop on that one, I believe 4 or 5 weeks ago. And one for Rust that was actually promoted 3 weeks ago. And still on there is actually the Node.js training that we created, and that will actually park somewhere next year because it's getting a little bit very busy at the end of the year. Okay. Yeah. Next to having a professional life, I also actually have a private life. I'm a proud single father of 4 sons. The 2 eldest actually have joined me in the company, and actually they yeah, sometimes help me write yeah, the different courses. They do the QA stuff, they can that kind of stuff. They're both actually on the University of Nijmegen. Doing computer science, never dreamt of one. Also, never dreamt actually that this would be a family enterprise and that kind of stuff. But actually, it's quite nice. Good. So that tells me a little bit about myself. Okay, I did already tell you the reason actually why I would like to give this tech talk. The big issue actually is that I've noticed that people are missing knowledge. Yeah, and not only this one, there's a lot of other stuff I can actually tell you. All kinds of stories, for example, about how people actually design stuff and actually, for example, make mistakes and actually bite themselves and that kind of stuff. And not because they actually are ignorant or something, but just quite simple. They missing some background knowledge and that kind of stuff, right? Because the CKA and the CKAD, they definitely give you the basic tools and that kind of stuff, but still, actually, you do not know enough. Actually, you have enough knowledge, yeah, as we call it, to be dangerous, but still, there's some stuff missing. So what we're going to do actually, yeah, I picked up a few topics. First one I've run into that's actually one that has my personal interest for a long time. There's actually not all the world currently is actually x86. Like in the past, for example, not all the world is VAX. Currently, actually, you have different kind of processor architectures like the ARM64s. Right now, actually, the RISC-64s are coming up. The first development boards, which are really nice with 8 gigabytes of memory, 2 network ports, 4 cores. And they're actually there on the corner. They will be delivered in January and February and that kind of stuff. But that's going to be one. If you look, for example, at the public clouds, both the Azure offerings as well as the AWS offerings, they actually now also offer you virtual machines that you can actually use with ARM processors. They're cheaper, they are more economically, less power hungry, so that actually leaves less footprint on the environment. So actually, building containers only for x86-64, that's actually not the common denominator anymore. Yeah, quite simple. Right now, if you bring something to the market, not only your application, for example, but also some stuff like the container network interfaces that we have for Kubernetes. Some of the other stuff like the ingresses, and actually most of them actually you can now find also in different architectures. For example, I've got a complete stack of Raspberry Pis actually in the other room. And they're in a 19-inch rack and that kind of stuff. And actually, I can run all the things actually just like I did on a x86. And my case, I was doing a lot of demoing actually in this case on a Raspberry Pi cluster of 6 Raspberry Pis actually there, 1 single master. But if I would like to, I can also actually have a high available and that kind of stuff. So actually, for me, actually, there's no excuse anything to not have my offerings, for example, the things that I build, that I create, actually not on x80, not on ARM64 next to x86, and maybe still I only have 1 board, so it's not enough to build a cluster. But when I have enough actually in February, then actually all the ideas actually to have also all the stuff that we have for the trainings and that kind of stuff, all the things that we build, the demos and that we can also actually run them next to Raspberry Pis actually on RISC Connect. And I know, for example, that Michael has some people actually in his courses in the past that actually asked how to run these kind of stuff actually on Raspberry Pis and that kind of stuff. So we're going to show you how to build actually containers for different architectures, and then in this case there will be, in this case, the ARM64. I'll show you actually how to run these in Raspberry Pi cluster, that kind of stuff. Another thing that we actually come and run into pretty often is actually the config maps and the secrets. And then again, this is actually going a little bit further than the CKAD. In the CKAD, for example, we learned the reason why we have config maps, why we have secrets. We learned, for example, that we actually can have them emerged in 2 ways, config maps and secrets in our containers in our pods. They can be emerged actually as environment variables. They have their ups and downs, cons and pros. We have learned, for example, that they can actually be emerged as file system, that kind of stuff. And actually they learn us actually how to notice or actually get the application notified, for example, to act upon the changed config map or secret, that kind of stuff. But actually, that's a way that we're actually going to topple over with a, for example, rollout via deploy restart, and actually the containers actually get restarted. Then they actually notice, for example, okay, something changed in my config map. The application is going to notice that, going to process the changes because it actually gets restarted. But that's actually a very rough way to do that. Yeah, I'm actually going to show you, for example, again, we need some programming language knowledge without that one. So I'm going to show you that how actually, for example, it works, for example, in Python, and for a little bit of time also in Node.js, for example, how actually to do that without toppling over the pods and that kind of stuff. And again, we can use this for config maps, but we can also use that, for example, for secrets. Another one that's actually been on my list, and I'm actually having a few talks actually with the Linux Foundation. I actually really would like to have stateful sets also in the curriculum, because stateful sets, that's actually the way to do really nifty things in Kubernetes. With stateful sets, for example, we actually go beyond the normal deployments and daemon sets. When deployments actually, or pods do not actually have identities of their own, they all actually have the same role, for example. Doesn't matter which one I'm going to delete and that kind of stuff. Quite simple. What will happen is the other ones will actually give me exactly the same service. The same, for example, for daemon set, although there, for example, the coupling actually to the node gives them some identity. But if I need to actually have pods, for example, containers of pods actually that have a different role, for example, when I have replicated databases, then I actually need to go into stateful sets. And the nice thing about stateful sets is always what I tell my students, and also the reason why, for example, we do have stateful sets actually in our training, is if you master that one, for example, you know all the items actually that are there. So, for example, you actually have, for example,
wij zijn vrienden
okay.
gedurende een jaar.
That sounds like a TV. Let me see if I can find who it is and mute him or her.
Dat is heel goed, dat heb je heel goed gedaan. Alleen ze draaien het om.
Okay, apologies.
Desamis,
That's French.
als er niks geen lidwoord voorkomt, is het altijd des. En vrienden.
Okay, if someone wants to learn French, I can also try to do it in French, but it won't work.
Dus dit is
Give me a few moments.
Maar vrienden, dat is zonder lidwoord, dan is het altijd nous sommes des amis. Weet je nog wel? En ami?
Willem, wil je jezelf even muten? Dat is wel fijn.
Dus zou ik het lekker zo doen. Ja?
Okay. Better?
Dank je.
Okay. Apologies, Willem. We do like the French, but it's English today. Okay, so the reason actually why we incorporate stateful sets in our course is actually it culminates actually all the items that you have. You learn actually how to do networking in a proper way with service, in this case, 2 different services. You learn actually how to couple persistent volume claims and that kind of stuff, how to scale up, scale down and that kind of stuff, and how to communicate with this one. So we're also going to do a small part of what we do with stateful sets. So we're going to demo a little bit, going to show you how it works and that kind of stuff. So, and again, that's part actually of our curriculum also. So, and if we have some time, then I'm actually going to demonstrate, for example, how we can do a green-blue deployment, for example. And we're actually talking about stuff in the Kubernetes curriculum and that kind of stuff, but actually, there's no question about how to do that, and that's actually fairly easy actually to do. So if we have some time, we're also going to incorporate that one. Good, let's get started. The first thing is that we're going to do is actually going to build containers for different architectures. Let me show you my environment. So that's not what I want yet, but no worries. This is a Raspberry Pi. If you don't believe it, you can actually see here, it's a 64-bit CPU. The Raspberry Pis are actually identifiable because they actually have here this serial number, for example, and this is the SOC. So this is definitely one. Has, in this case, 8 gigabytes of memory. And I already built a cluster. So this one is actually a 6-node cluster. I had some issues this early afternoon, but actually they're corrected now. Some updates with Ubuntu actually. This is my control plane, single. not high available, but if I would like to, we also have actually playbooks to do that. By the way, in the Christmas holidays, I believe it's on the 29th of January, I'm actually also doing another workshop that's about Ansible. And actually, in this case, my colleague Sander actually last year did a Ansible workshop together with me, also about doing Ansible with Kubernetes, actually building a cluster. I'm going to top that a little bit. So actually what I'm going to do is I'm going to, in the 29th, actually see and tell you, for example, how to design and how to implement an Ansible playbook, for example, that will allow you to deploy, sorry, Willem, could you please mute your microphone?
Het kaarsje niet, dan kan je toch gewoon de kaars uitslaan.
Sorry. Apologies, Willem, but I had to mute you. Again, back to this one. In the 29th of January, I will actually also deliver a workshop, but that will be about Ansible and actually how to design. So that's the first part. And then actually later on implement actually a playbook to deploy Kubernetes clusters, and then that you can actually choose which kind of a container runtime engine you actually would like beneath them. So you have choices like containerd, Docker, or for example, CryoD, that we can actually deploy it on Raspberry Pis and for example, x86 machine will be Ubuntu because we need to keep it a little bit close. And actually also, for example, create users on the cluster and that kind of stuff. So actually that at the end, we have a fully configurable, parameterizable actually playbook. Really nice if you're actually interested in that one. 4 days later, we'll do the same thing, but then actually for virtual machines or KVM. Okay, back to this one. So this is my cluster. What I'm going to do now, I'm going to get one back, and I'm actually going to show you this is actually a application in Node.js. Again, for all of the workshop, you don't need to have any special program language knowledge. For example, it's handy actually to have some knowledge about how things work, for example, how applications, for example, open up files and that kind of stuff, how they can actually find out, for example, a file has changed, etc. But quite simple, what I'm going to show you, this is actually a translation actually done by my eldest son of a program that I'm actually using, a demo program that I'm using actually in our courses. The demo program, some of you that actually have been in my course, that you know, it's called PyCon2 of the Python container. And actually what it does, it will show a Python container on the screen, draw and that kind of stuff. In a color, we can change the color actually by, for example, changing an environment variable. So that's the way it works. This is actually the same program, but they're not actually programmed in Python, but no code. It's actually programmed in Node.js. And I'm going to show you that, and actually going to also show you, for example, how to compile this on the different architectures and actually to create actually one container image that we can actually use to run it on all kinds of, in this case, two architectures. Of course, I can actually merge more image formats in that one, but currently I only have two different architectures. Once I have a RISC cluster also running, we can also try that, for example. Okay, let me first actually go a little bit into, because you see actually a lot of files currently on my screen. First question, of course, everyone can see my screen, I'm sharing. Good, I like that. So, okay, there's a few things that we can ignore correctly. For example, these Jenkins files, because actually I'm using this also in other courses, for example. The first thing that we're actually going to look in this is my normal Docker file. And by the way, there are multiple ways actually to create multi-architecture containers. There's also a way, one from Docker. There's actually using a really nice one called Docker build-x. And that, for example, will in the background spin up some containers. Actually, in that container will actually spin up Camu. And that means, for example, that on the same architecture, for example, x86-4, I can actually cross-compile and build containers actually for different ones. I'm not going to show you that one. Why not? Because simple, my systems are currently configured for Podman. So I'm going to show you the manual way actually to do that. So the first thing that we're going to do, we're going to look in this case on the Docker file you see here. So actually what I'm going to do here is I'm going to pull in the base image like we normally do for a Node.js application. Again, this is the simple part, because the other parts, for example, okay, how can we get the image actually as small as possible? And we can do that, for example, with multi-stage builds in there, but let's keep it one by one. So I'm actually going to say here that my work directory is app, and I'm going to copy in this case, because we're using in this case Node.js. So I'm going to copy in my package.json. That's actually the file that tells me which kind of a dependency I have. We'll look at it in a little bit. Again, you don't need any knowledge. Then actually I'm going to do an npm CI and an npm/clean actually to make sure that all the items actually are getting imported. And then actually we're going to do is pick up my application with all the artifacts. I'm going to say that something might be running on port 3000, and then this is just my normal endpoint. And actually of entry port. We get a little bit into the application. We'll do a little bit later on also, because I'm also going to this one, for example, to show you how to actually have your application, for example, respond to live updates in secrets or config maps and that kind of stuff. Yeah, this is the main source code. And again, you see a lot of stuff. You don't need to know JS for this one, but I will tell you, for example, where to look on. You can actually make the translation yourself. And later on, actually, I'm also going to show this, for example, with Python, because then we actually have a few lines instead of the whole stuff. This is actually being built in Node.js with Express and that kind of stuff. And it's a little bit more complicated. The part actually, what we do is we have a counter here and that kind of stuff. We actually have a function actually that will decode the color data, for example, do actually a color lookup from a table, then colorize actually the container by templating it with nginx. That's actually what we would have in Python, for example, with Jinja 2 and that kind. So no worries about that one. The whole idea is actually that when we actually go to, in this case, the port 3000, then actually we get a container. So I'm going to demo you that a little bit. This does a little bit more because we actually have colors, APIs, health APIs, ready APIs. There's a little bit like the gamification, for example, that you might get used from Michael's trainings and that kind of stuff. So let me go to that one. Then this one is the part actually that we were looking for when we're actually going to talk about the live updates, because this will actually watch the configuration file actually being updated and then respond to that one. But this is the important part. This is actually where we listen and where we actually will serve the application. Again, no specific things in this one. So what I can easily do actually to build, in this case, the specific application is actually going to do a podman build. Let me see if I get something running here. So podman build, for example, and I do it now just in the normal way. So now without actually taking into care that this will actually be a multi-architecture build, for example. So let's call it. This one's called Nerco, and we call it the IT Guild V1 build, for example. Did I do this right? I do believe so. Podman build. So now it's going to build the container. Podman, of course, we have a big difference with Docker that actually Podman actually will try to build this stuff actually in my local home directory, and actually it's already here. So let me see if I have any containers running. PS does it look like? Let's see if we can test it. And then later on, what I'm going to do is I'm going to retag it to make sure that it's a specific version actually in this case, because this architecture is actually a x86-64. So what I'm going to do first is test it, run. Okay, what would I like to run? It's Nerco, version was x86 v1. I know in this case that the application, if I'm correct, is running on port 3000. Let's pick up that one. And of course, I would like to run it in this case detached. Let's see what's there. One PS. That looks okay. And if I do here, call localhost 3000, then we can actually see here the text. Of course, seeing is believing. This one says that it's a gold container. And let me now go to a web browser. Yep, let me go to a web browser. Pick it up. HTTP to the machine. Like a port 3000. And indeed, this looks like a gold container, and it actually has a visitor counter. It's not really fancy, that kind of stuff, but we're going to use that a little bit later on also. But here we can see it's working. In this case, says it's for version 092. What we're going to do now is I'm actually going to build it again, or can retag it, for example. And I'm going to make sure that in this case, this will be a version that's been marked actually as a x86-64 image. Then the next step that I'm going to do is actually I'm going to do the Raspberry Pi. So in the ARM64 architecture, I'm going to do the same build. And then actually we're going to merge both of the images, and then we're actually going to see if with the same image stack, we actually can run this, for example, in Kubernetes. Okay, let's do that. So the first thing that I'm going to do now is make sure that I got my Podman build back. Okay, and then I'm going to say in this case, this was v. And then we call it, in this case, for example, x86. Okay. Now what I'm going to do is do a, actually I could do this nicer. I'm actually typing it. I know. Hopefully that I won't get bitten by the API rate limiting, of course. So this will be okay. Yes, this looks like it. Okay. Now I'm going to push it. It might be that I need to log in. We'll see that. Okay. Looks like I do not need to log in. Okay, it does say some fail to, but now log. I need to log in. You know, if it doesn't work, I'm actually going to use Quai. Push. So what happens now is that my image is getting pushed in this case to the Docker Hub. You can also use Quai. You can also use your local, for example. I did have a harbor actually configured, but that one has some issues. So I need to look into that a little later on. Now it's actually there. That's good. The next thing that I'm going to do is now actually do the same thing, but then on the Raspberry Pi. So I'm going to this guy's into my cluster. Good. And to show you that this is indeed an Arch64. That's an ARM64 one. So what I'm going to do now is, of course, we can go to the local one. And I'm going to do, let's see if I have Podman here. I do have Podman here. It's good. So I'm doing a build again. And then we're going to tag it differently. Docker.io. And then let's pick up Merco. And this will be, in this case, the ARM64 version. Build it. This one is a little bit slower. It's not that powerful machine like the Threadripper I was running on the first part. But actually does exactly the same. By the way, this only works, of course, if the base images, for example, are available for the architecture. On ARM, for example, most of the images are actually there. Say 3-4 years ago, this was actually a very poor experience. But right now, for example, I got Node.js containers, I got Python containers, I got Alpine containers. Currently, for example, for RISC-64, because I'm already busy with that one, we actually run into issues that, for example, the base image is not there. So I cannot really easily, Go programs, for example, that's not an issue because Go actually takes this whole runtime. I actually don't need libc and that kind of stuff. So I can actually create a container, for example, that's almost, it's actually distro-less and that kind of stuff. And then you can really easily actually create multi-containers also, for example, of multi-architecture containers also, for example, for RISC-V, for example. And for these things at Node.js, that's a little bit more difficult because actually, the Alpine is not really stable yet. If we can build one, and actually, and on some of the other registers, for example, they already have these base images, but you need to look a little bit further. When that has matured a little bit later, and then actually, I'm also going to do a workshop on actually running, for example, Kubernetes on RISC-V 64, but that will be most probably April when I have all the machines there. Because with one board, you can't build a cluster. Okay, so now what I did is actually I've got 2 images there. I got Noco v92 -ARM64. That's the ARM64. I got another one that's actually also there. That's actually in this case x86. Let me see if we can actually find that on the top. Now we have to look at, no worries. So what we're going to do now, I have to improvise a little bit, is we are going to make sure that we get a multi-arcs on this one. So I'm going to actually pick, in this case, one of the scripts, and we're going to actually rebuild it a little bit. So I'm also going to tell you what it does. Good. afternoon, Alessandro. Welcome. We have started. We're currently busy with doing multi-arc builds of containers. Okay. Into that. So the whole goal actually for this one is what we would like to do is actually create a container image that contains actually the images of both the architectures. So as well as the ARM64, as well as the x86-64, for example. And that means, for example, what I would like to do is if I do a Docker run, for example, then automatically the container runtime engine or podman run, for example, finds out actually, okay, this part is belonging to the x86-64. So actually I'm going to download that one. The other one, I'm not going to do that. And then if I'm, for example, running on an ARM64, it will actually download the ARM64. The whole idea is actually that these images have a format that's been standardized. That's one of the great things actually that we are grateful for Docker. And that's actually called a manifest. And the manifest, for example, describes which images actually it contains. So that's what we're going to do first is I'm going to, and let me do that with a little bit of a side note, IT-Gilder, for example. What I'm going to do here is I'm going to create, in this case, let me do that this way. I'm going to create a manifest. The manifest is actually in this case named after the tag I'm going to give, because what I do not want to do, for example, is that I need to remember, for example, okay, I would like to run no code, but on a x86, for example, I need to type in no code colon v4 x86, for example, and on an ARM, for example, v4 ARM and that kind of stuff. I would like to have, for example, okay, there's no code, would like to have version 0.92, for example, and runtime, container runtime, please go figure out which version, which architecture you actually need. So that's what we're going to do. So actually we're going to use, I'm going to remove a previous manifest if it was there, if it's like of our previous image if it was there. If not, we're actually going to remove that one. And here we're actually going to create it. And then what I'm going to do in this case, I need to change this a little bit. Let's pick up, this is for the ARM, what I call it, to ARM64. I'm going to put in this case, it's actually the QI is actually in this case Docker. And again, the reason why I use QI is actually that the rate limiting of Docker can be obnoxious sometimes. So actually going to do here is this would be v9 to ARM64. So I'm going to pull here the image in, and then I'm actually going to do is actually add the manifest of this image to the manifest that I created here. So first I get an empty manifest, and then I'm actually going to add the manifest actually of the first image. Then I'm going to do is pick up the second image. And of course, this one is also coming from QI, from Docker, not QI. And this one is called 392 x86, if I'm correct. And we're going to do the same thing actually to this manifest here. I'm actually going to pick and also add the manifest actually of the x86 version. Okay. And then what we're going to do is I'm going to push everything in this case to the Docker one. Let me do that. And the whole goal is actually now that I will be having an image called Noco v92, and that should actually have then both the architectures in that. Okay, let me see if I didn't make any mistakes, because most probably that will actually some headaches. No worries, it should actually go okay. Let me see, could be making some mistakes with the naming, but we'll find it out. We'll see. Yeah, that's the first one. Errors is okay. That's not a problem. This actually says I couldn't find the image. The other one are a little bit more. So this one says I didn't find the ARM64. Okay, that needs to look at it. But I can really easily do that because actually that's one I created on this machine. So okay, so having quite some issues. Let me check. This is going to be a funny one. So this is v9 to ARM62. That was actually should not be an issue. That's actually a Docker IO. So let me check what's going on. Okay, pick it up. So this is 392 ARM64. That should not be an issue. That's what I have. Okay. That's a one. Same thing. That should not be an issue either. Okay, this is the x86. Now I need to check that one. That might be. How do we do that? Let's go back to the original machine. And no, should not be an issue either. So let's check that, pick it up. The demo gods are a little bit against me, so actually I should have made some offerings to them. No worries, only makes things more fun. So I'll back to this one, and then to okay, that's it. Good. So let's see what we can do. This is the fact. This is my day. Okay, we got log in. What man log in? No, oh, that would be something really nasty. We have Docker. No. No. Good. Another try. And then watch these. This one still says I don't do that. Can manifest a no. That's strange. Okay. Then let's do something else. Docker pull. So Podman pull. Picking up. I get this one. That's not a problem. And I get this one. That one says that's manifest and no. That is weird. Okay, no worries. Image selects. Could that be that I forgot? Hotman. Looks like I forgot that step. Now both are actually in the. Okay, let's see. Okay, that's better. So now it pulls in the first one, and actually it's quite simple. It already has that one. Now the second one. Now it's storing the signatures. Let's see if that one works fine. Now it's actually pushing the resulting one. Okay, now we have a good one. So what should be happening now is the following. If I do this now, Podman run. And again, first let's run it in Podman and Docker mode, just in container mode. So what I'm going to do is -p 3000 Docker.io. This is my repository. And then what I'm going to do is, in this case, no code p92. And actually, we should not pull something. And if I'm very correct, this should actually run. Goes and picks it up. Yes, let's do a Podman PS. Then it should run. And actually, I'm now running in this case with this image on it. And of course, the proof of the pudding is in the eating. So if I do a localhost 3000 here, it runs. So, okay. Proven that it runs on a Raspberry Pi. Now let's go further to the other one. So I'm going to do here the same thing, but first, of course, I need to remove my old one. And F. And go to remove that part. It's a little while. Okay. Oh yeah, no worries. That's okay. Run. Okay, let's have this one here. Again, not specifying. Hey, it's the same image, not specifying any architecture and that kind of stuff. And this one said, okay, we didn't have it. Okay, that's not going to work because I'm not that important that I do have my own namespace on the library, so I need to do that myself. This one is there. And by the way, it looks like it doesn't actually pull anything in because it has everything. And actually, that's completely okay. And that's completely true because actually what I'm having here is a manifest with both actually the layers for both architectures. And they were actually building the machine. So yeah, it's actually saying, okay, quite simple. I already have these. It's not a problem, but now let's see if it indeed has, because I do have the same image, of course, and you can see that here it's V92 without any specification of the architecture. Proof of the pudding is in the eating. So if I do this, 3000, that should. So that works like a charm. Good. Let me now close this one up. Pop on RM-F and delete this one. If there are any questions, just let me know. Just let's keep this interactive as possible. Things might go fast, things might go even be a little bit chaotic due to the night, to the evening, that kind of stuff. But I'm there actually to help you if you have any questions. Good. Just come. Now let's go back to the Kubernetes cluster. Told you got actually a 6-node Kubernetes cluster here running on the Raspberry Pi. Let's see what's actually already running. In this case, a NFS client provisioner. You're going to use that a little bit later. We're going to talk about stateful sets and a Prometheus MySQL exporter. We're not doing anything with that one. So what I'm going to do now is going to say kubectl, create deployment with an image. What would I like to have in this case? My own. Let's do it nicely, actually. And my namespace. Pico, sorry, no code V92, and do me 4 replicas, for example, and I know something is running on port 2000. It says you need to specify the name. You're completely right. So we call this one no code, and I'm going to check now. You'll see that 4 of these guys should actually be running. And in a few moments, let's put a watch to it. And again, depending on your program language, this is easier or less easier. For example, 4 weeks ago, I was actually demoing, you can see it's coming up. 4 weeks ago, I was demoing actually Go. And Go is a really nice language because actually with just on each and every system, actually all the cross compilers already in there. The only thing that I need to do is actually change the environment variable Goose, for example, for the operating system, Go Arc, for example, for the CPU architecture and that kind of stuff. And then actually I can build stuff and I can do that actually inside of my Docker file, for example. I did also show that, for example, there's actually a tool from Google that's called Co, and Co with KO. And KO actually, but the only thing that you do is, okay, quite simple. This is actually my Go program, and create and draft the Docker file for me. And by the way, these are the architectures that I would like to run it, and actually will create one image with all the different container images in the manifest that actually you gave. And if, for example, say all architectures, it will actually do that for all the architectures that actually Go supports. And so you don't need to do any cross-compiling on your side. 2 weeks ago, I actually demonstrated, for example, the Rust programming language. And Rust also has cross-compiling, although it's not as easy and not as nice actually as we have in Go and account, but again, different kind of language with a different kind of, let's say domains and that kind of stuff. But also with Go, we can actually do this kind of stuff. Okay, we have it now running. Now the proof of the pudding, of course, is, let me first see if I get the IP addresses. There it is. And if I pick one, for example, this one, by the way, is running cilium. And you can see actually it's running like a charm. So this is the way actually to build a multi-architecture image in in Docker and Podman in this case, and actually run that, for example, Kubernetes. Again, there's another way. I'm not able to demonstrate that now because my systems are all running Podman. I'm actually trying to steer away a little bit from Docker. But actually Docker has a real nice option that's called BuildX. I can actually show you how it looks like, but I cannot demo it, unfortunately, so please forgive me that. What you actually can do, for example, with BuildX, you have a command like this, docker BuildX, build. And actually what you have is then a so-called build builder actually configured. And for example, you can then use your Docker file, you tag it, and of course, this needs to be a space. And then here you can actually specify your platforms. RISC-V, for example, won't work because we don't have, in this case, a Node.js, for example, image for that one. It's actually not an Alpine, that kind of stuff. But this, for example, will do a few things. First of all, it will actually build the containers for each of the architectures you specified. And again, you need to use, in this case, Docker CE for that one. So it will not work with the Dockers, for example, that have been compiled by Red Hat or, for example, Ubuntu, that kind of stuff. It really needs to be Docker CE from the Docker website. And then actually it will compile it for AMD 64, ARM 64, and ARM 7 hardload, for example. And when it has done that, it will actually create, in this case, one manifest under this name. And then also, for example, push them actually to the Docker, of course, because Docker supports Docker and that kind of the Docker registry. So, any questions? Good. Okay. And then what we're going to do is go to the next topic. So one down, two, maybe 3 to go. We're going to look at consuming config maps. So what I'm going to do here, I'm going to rehearse a little bit of the slide section I'm using in my course. So actually, please give me a few moments. Let's go to that. In the meantime, can someone tell me, for example, what I use config maps for? What's the purpose of config maps in Kubernetes actually? Can someone tell me that? Okay, now let's actually go through that. Okay, a few moments. Yes, okay. Config maps. Yeah, config maps actually, we not only have them in Kubernetes, we also have them, for example, in the past actually still have them in Docker Swarm, that kind of stuff. And actually what we try to do with config map is actually separate configuration information from the container. What we actually would like to do is have a container image that we can actually have as pristine as possible, and test that one, for example, on development, then test it on the test environment, and out without changing anything to the contents of the container, put that to QA, and actually deploy it on the production environment. But of course, for some items, things do definitely change. For example, in the development and test environment, if I need to connect to a data source, then that mostly will not be the real database. What I always use as an example is that in the Netherlands, for example, when you speed a little bit too much, you actually get photographed and that kind of stuff. And your car is nice, the license plate needs to be on the photograph, on the picture. And then actually another part of the government is actually owning the database. And then the police, for example, needs to connect to the database and then actually finds out who you are, etc. Because in the Netherlands, actually, license plates are connected to the car. A car is actually an owner, and that's also been registered in this case by the Dutch IRS and that kind of stuff. Very complex, but actually. But if you would like to make, for example, a new application that does something with license plates, because in the Netherlands, because license plates are actually related to the car. If you know the license plates, you know what car it is, you know the age of the car and that kind of stuff. So also, if you would like to make an app, for example, that you can photograph a car, and I believe it's completely illegal, but say it's possible. You photograph a car, and then actually with OCR, with recognition, you can actually read the license plate. You look it up in the database, and you can see, for example, okay, this would be, for example, the day's net worth of the car. So you could make an offer actually to the owner to buy it and that kind of stuff. But that means, for example, in test, no one is actually going to allow you actually to connect to the database. And development also, what we normally use as developers then is stubs or mocks and that kind of stuff. Or we use a test database. But that means, for example, the connection string to the database, to the mock or the stub, that will be different for any of the environments. In QA, most probably I may be allowed to connect to the QA database, for example, the official one. And of course, in production, I'm allowed actually to connect, if it's so, to the real deal, to the real application. But that means in this case that these connection strings, they differ. And I would not like to have these connection details, these configuration details, actually being part of my container image. So they're used to separate configuration from the container image. And importance, we have another item that's actually, in this case, secrets. And secrets are also a kind of configs, but they are actually more there for more private information, more secure information. The only problem is that out of the box in Kubernetes, secrets are actually not encrypted. They're actually base 64 encoded. So everyone you actually get from the street that knows the base 64 -d command can actually decrypt your. So in order to do that, to make it more safe, we can actually encrypt them at rest. But that's part of the CKAD code, for example. But again, all the things I'm going to tell you now works for config maps as well as for secrets, etc. Good. So pod containers can actually access config maps through a few two methods actually. And one is actually environment variables. What I'm actually going to do is then I'm going to consume the config map actually inside of my pod. And then actually they appear as environment variables. Of course, this has some cons because quite simple. Environment variables, for example, actually get set up during the startup of the container in the pod. And that means that during startup, actually, we use that mostly, for example, to configure a MySQL, a set as root password to create, for example, the initial database and that kind of the initial users and that kind of stuff. Once, for example, the config map changes during the lifetime of the container in the pod, they're quite simple. It doesn't notice anything from the changing in the environment variable. So, yeah. The other way to do it is actually with mounted volumes. And actually what I do then is I'm going to manifest the configuration data. Mostly there, for example, key value pairs, but it could also be complete files. I'm actually going to merge them as part of a file system. So I can get a directory. And in this directory, for example, what you will see are these files. And in these files, for example, the files are then have file names. They're actually the keys. And the values, the contents of the file are actually, in this case, the values of the keys and that kind of stuff. The good part is that if I change these, for example, after a while, it takes some time actually for the update, actually the contents of the file definitely do get updated. So there's actually a way to make this more dynamic and that kind of stuff. The only thing is that I still need to have an application, and that's actually the part that we do in advanced CKA, for example, to make it actually respond to changes in the volumes. And actually, that's not really trivial. So I'm going to go with you. We'll need some time for that, so no worries about it. And actually see what's happening there and actually how we can adapt our programs. So actually, we need to have developer knowledge for that kind of stuff. And for example, act upon these changes in these volumes. Okay, but first, let's talk a little bit more about the ways. So actually, I can create a config map at kube control create config map. We all know that. We give it a name, and then, for example, in this case, what I can do, I can even, for example, put a complete configuration file here. This construct, for example, is, for example, what we use in the stateful set example that we're going to do as last part of the workshop here. Another way is, for example, using key value pairs. So, for example, what I can do is I can create a config map, for example. Let me actually do that. Pick this one up. And, copy. On my cluster here. And that's CM. So I'm going to create a config map, my config, and actually this will be, in this case, from literal. And then here says the color is the key, the value is red, and the other one is here, the key is mascot, and the other one's also. By the way, people are asking, okay, why this one? Well, quite simple. I did deliver this one time for Salesforce, and of course, these have these nice mascots. One of them is actually called Astro, and a few others also, and that kind of stuff. Actually, we use this one for that. How does such a config map actually look like? If I check, for example, with kubectl CM. You actually can see it. This is actually my conf. You can also see, by the way, for example, here in my default namespace, I also have a kube root CA account. So actually config maps are very common actually way to put configuration information actually for containers in a pod in Kubernetes. Okay, you can also do a describe of this one. So if I do a describe, and then, for example, CM for my config, then actually we see here the data. So in this case, the key is color, the value is red, the key is mascot, and the value is astro. You can also, of course, see how this is representable in this case. So not see pod CM, and then in this case, the my config in YAML. And actually what we see here, now we got our kind config map, we got some metadata, and here's actually the data. So we see actually here a key value pair. So, okay, good. Let me check, yes. Okay, so this is how it looks like in YAML and that kind of stuff. So now go to that. Now let's, for example, try to consume this. So, and we can actually nicely do that. I'm going to blatantly actually copy this one. So I might, of course, lose my complete environment. YAML. Will completely lose the no worries. Let me tidy it up a little bit. Got my API version. The kind is a pod. I'm going to use some metadata. In this case, spec, certification, containers is part of spec. This is the name of my container. I got an image here. What I'm going to do in this case is I'm going to have a, okay. Another one waiting in the room. Come again. Good. Welcome. See, actually, AKMS, that's nicely aligned. Containers. This is the name of my container. Got the image. In this case, I'm going to do is color, and that's a value from. Yep, almost. Value from configMap. Well, let's see if it works. Takes a little while. Okay, so it's parsing, line 13. I made a mistake. Nothing value is not allowed in this context. Yes, logical. Good, that's there. Let me see. That's container creating. Might be that because I didn't check that. I'm actually picking my config, picking up color. Okay, good. Let's just go back off. Let's see what's happening here. Describe path, a container. This one says back off restarting. Let's see the logs. Logs might be that this is actually not for. Oops, sorry. Control logs and then E. Yes. Demo gods, I'm not with me tonight. No worries. Unable to configure cool logs. They're definitely not with me. Yeah, okay, this is not the problem. Okay. What this one says is this is not configured. Okay. Can I do that? No, I cannot do that. No worries. Good. Let's do this. Yeah, it doesn't matter. Good. It's only that I have something. Okay, keep control. Yeah. The idea is, of course, was just, of course, demoing the multi-architecture capable images and that kind of stuff. This was actually that is not. Keep control, delete, color, container. So, and the only thing is actually I would like to try and show you how the environments work. So I can just use any. The next thing I actually would like to do is, for example, okay, let's then do Yahoo text basic box, for example. But that one is also only compiled for x86 and not for ARM. So that's the reason why it goes wrong. Again, no worries. Free debugging, free troubleshooting. Keep in control. Apply. F, CM, and okay. Creating. It's a while. I'm sorry too. Let's see what's in the container. So now actually see something like color. And we can see here in this case that the environment is actually colors red. And what I'm going to show you now, for example, if I'm going to do this, Q control, edit, configMap, my config. For example, make it green. This is not going to change, never. The only thing actually to make this change is actually what I need to do is I need to stop the container and actually start it again. If I have a deployment, what I can do is actually using a routing upgrade to actually topple over the pods and then actually have them forced actually to get the to read the new environment variable and that kind of stuff. But that's not really what we like to do. Okay, gentlemen, you've been listening to me for an hour, so we're going to do a 10-minute coffee break. And after that, I'm going to show you, for example, how to do this in a more nicely way. First, I'm going to show you how to do this actually in this case with mounted volumes and that kind of stuff. And then I'm going to show you actually how to make use of a little bit of an intelligent program, or a little bit of an intelligent action in the developer, and actually have the program actually act upon changes in config maps and secrets, etc. Is that a good idea? Good. Then I will see you back in 10 to 15 minutes, okay? Thank you. Yep, that's also an option. In 5 minutes, we'll resume. Okay. We got to move to another cluster for the rest of the demo and the workshop. Actually, let's see if this one is healthy. It's a little bigger cluster. It's actually high available. Okay, looks good. No, not high available, by the way, also single master. Yes. I've got, where is Rumble? Way around. Okay, what we left actually, and apologies for searching all the files back in order again. What we left actually prior to the break is we had talked about config maps and kind of stuff. We have two ways actually to have the config map actually manifest themselves in our containers in our pods, actually to consume that one. One was using environment variables. The big issue with that one is actually that we cannot dynamically update them. If we, for example, are going to update them, what we actually need to do is we restart the pod so that all the containers actually get restarted in them, so that you can actually, for example, start up the program again and read the environment variables again and act upon that one. The other way that we can do is actually having them manifest as files, but that's also not really easy. Okay, let me show you first. So I'm going to pick up, this is actually a x86 cluster again. So what we're going to do here is I'm going to pick up a small, let's say less complex example, in this case in Python. I'm going to show you in a few moments. First, what I'm going to do is I'm going to apply another config map here, also again with color. So I'm going to do that. So here. And what I'm going to do in this case, first do a PyCM environment deployment here. And that contains, in this case, 3 replicas. In this case, of a program called PyCM environment v1. We're going to show the program in a few moments. And again, it does exactly the same thing as we had actually in the slides. And so actually what it will do is set an environment variable in this case, and called color in capitals to the reference actually of this key, and then of actually this config map, and actually belonging to the value actually of this key. So let me do that. Y minus F minus CLS. Deploy the YAML. And let me check now. And in a few moments, it says here in this case, PyCM container creating. And in a few moments, it will be there. It takes its time. It's running. If I do this now, right? I'm going to check inside of the container. Do an end, for example. Actually, do color. Okay, where's my color? Okay, so, okay, something strange happens here. Let me see. Environment deploy. I'm setting definitely the environment color to that one, and actually, it doesn't complain. So I did find the config map. Get pods, control, describe pods. Yeah, good. No, it's not an issue. It has that. Okay, yes, that filter sync config map timed out. It did have an issue, but that's strange. I actually picked it up again because otherwise we get a pending, so that cannot be the issue. Let me do a control. Deploy. What's my deployment called? It was called Py. Oh, that's nice. Yes. Yeah, I'm actually having too few sleep, I guess. Keep control. Which apply did I do? Because I have applied the wrong part. See, yeah, that's not what I need, because that's the next step. We need to have this one. Apologies. Not delete, this has done apply. Parts. Good. Keep control. Check. Of course, these are changed. If you have any questions or comments, just do not be shy. Good. Yeah, colors red, so that's good. So that works now. Okay, and the only way actually to change this, that's actually this part. Click control, yeah, CM, control edit, color CM. Map, color CM. I'm going to make this one green. And again, this one will work. And if I check cube control, rollout, restart, deploy, Py, CM, environment. And this is what we learn in the CKAD. So if I check now, of course, the pods. then there's now using a rolling update. We see the old ones still, and we see new ones coming up and that kind of stuff. This is a new one. You have the old ones, and one of the old ones is actually getting terminated. Let's pick up a new one. That will be this one. Actually, here already one is running. So picking up this one, and if I actually do my exec trick, in this case on this part, that should show me green. But again, that's actually by toppling over the pot. And so the containers in that one, that's actually a rough way to do that. So now you can see the color is green. So again, that's one way to do it. If we actually have the option to actually write a program that can act a little bit more intelligent on this one, we can do that. So let me show you that. This is the source of my program. In this case, we're having a logging actually just with the environment, for example. But we can also actually, and let me show you that in a different way. So now do this in with a backup. I'm going to delete my old deployment. Minus f cilium and deploy.yaml. Okay. Then pick up, in this case, I'm going to mount it inside my containers, but then in this case as a file system. Yeah, here we have that. So still the same thing. I'm actually going to, in this case, mount my original one, my config map with actually this environment, but I'm not going to pick up the environment again. What I'm going to do is we're going to mount it inside of the pod access and file system. In this case, under add config, and actually use the same config map for that one. So let me do that. Apply -f. And, this one. Yes. Good. Then let's do a clip control pods. Okay, then I have here the file systems running, so I can actually go inside of these exec -it. We have now a file system here, ls-it, and you can see here we have color. Okay, and color actually contains now green, so that's great. Okay, now watch carefully because this is actually the whole trick that happens. And we actually would be actually nice if I would do this. I'm going to copy this state. I'm going to go outside of it. States. Up. Let's put that this is green. And again, it's not as trivial as it likes, or as it looks like. One, this is green. Okay. What I'm going to do now, I'm going to add it up my config map. First, need to know which one it is. Cube, control, edit, config map, CM, I guess. There it is. And I'm going to make it orange. Just on national colors. Okay. Let me see that it did do that. So describe CM, color CM. And actually, this one is orange. That's good. Now let's go back inside of mine. So here, actually, a little bit color. Yes, it has up. So this one has already updated it. So you can see this one is dynamic. Okay, but now the whole idea is the following. So picking up this one and let's compare. Okay, picking up exit. And now pick up states. 2 orange. Okay, let's okay. So this is what we have. Okay, let's check. So this was the original state, and actually, quite simple. If we look at it really naively, then the thing that we need to check, for example, is we can do that in modern languages. So we have something called inotify. So it's actually called the system call in Linux. And what inotify actually normally does is that I can put a watch on an inode. And if that inode changes, then actually something changed to the file. And that could be that, for example, someone touched it. So the daytime, for example, C time and that kind of stuff, A time is actually being changed. It could be, for example, that including that, of course, the size is described actually in the inode to change the name and that kind of stuff. So, okay, but the problem is this is a link. Yeah, so what you see here, this doesn't actually change. This actually keeps exactly the same thing. But if I look here, for example, where this link is actually going to, it's actually going to the data color. Here data, and that actually goes back to that one. So actually what we need to do, a few things. We could try to actually find out and link through, for example, and see if we actually reach the original file. The other thing that we can do, of course, is actually just watch the parent directory and see if anything changed there, because actually that's all I need. It is in this case, and I'm doing a little bit more robust, or actually a little bit more with a big cannon, that kind of stuff. I'm actually going to say if something changes in this directory, then it actually means that the config map has actually been updated. And the same thing is actually what you can do for a secret. But important, please do not watch, for example, the color file. Okay, the color is actually the key. The content of the content is actually the value, but that link doesn't change. Yeah, that link stays there. The only thing it goes here to the date color. And actually here we have to have that one, and actually we go here into this thing, and then actually the original one that's actually containing the data. So what I'm going to do is actually I'm going to check in this case on the directory and actually do an iNotify on that one. If the directory gets updated, it means actually that in this case my config map got updated. Of course, for the secret, it means actually that my config map got updated. Okay, how can we do that then? Okay. Let me go back now. So, and then I'm going to need to. Let me see if I have it already here. I don't. Yes, I do have it. Okay. Yeah. That's actually it. So what I'm going to do now. Now we get a little bit more into the nitty-gritty details. So actually what I'm going to do now, this is in this case Node.js, but you can do the same thing, for example, for Go, for Python, for any program language actually that does have in this case the iNotify. Right? What we actually do here with Node.js, for example, using some promises actually, we're using actually callbacks and that kind of stuff. So, but actually what we do, let me check that here. And this actually also has a counter, for example, we're going to use that one. It's actually, let me see. It's somewhere around it. Yes, async function. So this is where we color the container, for example, and this is a watcher. And so actually what I'm going to do here, the container config file, and if you look at that one, config file, that's actually here. And so in this case, the settings color directory, the settings color file. I'll keep it that up. So container config file. Yep, base, settings color, watch. We're actually going to watch that one, and if it, for example, changes, then actually we're going to actually act upon it. So then actually what we're going to do is to read it, and we're going to actually, in this case, pick up the real part. And the real part in this case is the directory itself, not really the term. So if that one changes, then actually we're going to act upon it, we're going to color that one. Okay, how does that look like? Because actually it is actually more on the result. So let me double check that one. Do I have the Kubernetes files here? I do believe so. Yes, that's nice. So I'm going to do in this case this one. Let me show you that deployment. Config map file systems. Yeah. I'm going to deploy one in this case with one replica because that's enough. And actually, oh, this is nice. This is actually, I can do that on the other one also. And that's even more nice. I do that. We still have what we wanted to do the multiple artist touches. This is okay. And then deployment. Yes, system.yaml. Oh, come on. YAML. Apologies for the chaos. It has some nice things actually by doing this kind of stuff actually on the different architectures. But it would be great actually if that then also hold up. It doesn't. No worries. That's this one again. Okay. Good. And pick up this one. I need to be very, very careful now. Okay, deployments. YAML. Okay. Control, apply, F. Might go into flames, but we'll see that. Okay. Apply for tmp2.yaml. Let me show you also. So there's actually another config map with the color configured in this one. So in this case, it will be orange. Now let me see if my image is actually there. So this one says no code. Okay, container creating.
Ga je naar beneden? Kun je dat
Yes,
meenemen?
please.
Voorzichtig, laat die van. Wat zegt het pas?
Yeah, it's good. Pick the config map, color config no front. That's logical because I created it after that. Now it's actually there. So let's say what it says. Keep control can plots minus O white. So curl. Pick up here the IP address.
Als waarde moet bij tellen bij het loop. Dus hij maakt wat significa moet bij tellen bij het loop.
Sorry, Zafar, I need to mute you. Okay, you can see here that in this case, it's the orange container. And this one has extensive logging. So let's see, keep control pods, keep control logs, and then actually pick up this one. And what we can see here, that says actually in this case, it looked up the color, it was orange. Okay, now let's see if it actually also, for example, what I'm going to do now is update it. And the goal is actually the same thing to make it gold. So I'm updating it by applying a new version to that one. So now it's still orange and that kind of stuff. Let's see if I can get inside of the container. SSH. Let's see, this one is I believe also our config. Yes, this is colors.txt. That's what we are watching. This one and this, that's not the one we're watching. That is my file. Let's see that. Settings, that's it. Okay, color. And this one is still orange, so it still needs to update. It's actually what happens is that Kubernetes actually has an update cycle, and it can take up to 30 seconds before it actually has updated it. So this one should be getting into the gold. You can actually also do this way. Settings, color, still orange. Let's see that it works the same way actually with these symlinks. Now it's gold. So let's see if the program also found that out. You can see that with the logs. And you can see that what it did here, due to the iNotify, it had a change of color due to color file change. And then actually it colorizes it. And if I now, for example, do indeed the curl on the directory, or a curl on the URL, then we should have, in this case, the gold container. So this is the way to update config maps and secrets and have your application respond to it without doing a rollout restart. So this is really zero downtime. When I do a rollout restart, I get near zero downtime because actually what I'm doing is, of course, creating a new one that has actually the updated config. But if I would actually be served by the pod that's actually being killed, for example, if I happen to be in there, I need to refresh my screen. So it's actually near zone downtime and not downtime. Any questions about this? And again, you can implement this in all the modern languages. The only thing is that you need is actually an iNotify. And the second takeaway is do not actually iNotify. Do not watch the link because that will never change. Watch actually the directory where the link is in, because if the updates are actually in these .dot files, for example, they actually signal there as a change in the configuration. And you could actually do it really nice. You can actually completely pause that, for example, and only respond, for example, that a certain file, for example, gets updated instead of all the files, for example. All that kind of stuff is possible. But at the basics, is quite simple. Check on the directory, on the parent one. If that does change, it actually means that the config was updated, and then your program can react to that one. Are there any questions? Good. Okay, we're running a little bit late, and I need to unfortunately leave at a quarter of actually at 9:30. So what I'm going to do is I'm going to put up the other one, the stateful sets, actually for a next time, if it's okay with you. And that's actually also a nice one. We're going to do that. I'm going to explain actually how we use stateful sets, how you can actually create persistent volume claims for that one, how they work, but also, for example, how to make sure that the stateful set, once you actually stop them, for example, knows how to find its persistent volumes, etc. again, etc. Is that okay? Good. Okay. Then, are there any questions about what we talked about?
No, not at the moment, Pascal.
Okay. Good. Yeah, now I say, well, let's wrap it up, and I'll hope to see you in the further classes also. Okay, the next one actually coming up is the one on Ansible, and actually writing and designing a playbook to create actually a fast way to deploy Kubernetes, including multiple choice of container engines. So both of actually all three of them, Docker, Containerd, as well as CryoD. Also, actually, for example, directly installing a container network plugin, for example, Cilium and Calico and that kind of stuff. So it's real fun.
Cool.
Good.
A lot of
Okay,
work.
guys. Yeah, it's definitely. And next time I'm actually going to schedule a little bit earlier because I noticed that I get tired in the evening after 10 hours of work. So apologies for that, for the chaos, guys.
No
Okay.
problem. Oh, thanks a lot, man.
You're welcome. Many thanks for your attention, and I hope to see you later. Enjoy your evening.
See.